Calculus Unit 5, Day 40 notes. This is part 4, last part here. Couple problems. So explain why you cannot apply the mean value theorem for the function f of x equals x to the 2/3 minus 2 on the interval -1 to 1. Well, mean value theorem, if I come back um, right here, tells us that the derivative is equal to, which is the tangent line at some point C, is going to be equal to, the slope of the tangent line. And we need to delete that line. Sorry about that. Okay, so let's go back and start with the derivative. So I know, and it has to be continuous, and it has to be differentiable. So the derivative, and I rewrote it as f of x equals, again, this is what it is, cube root of x squared minus 2. So the derivative of this function is equal to, bring the 2/3 out, x, and then we subtract 1, and that's going to be plus 0. So let's rewrite this as 2/3 times 1 over x to the 1/3, and we'll just write this one more time. 2 all over 3 times the cube root of x. So there's a problem with this. It's undefined. The derivative is undefined when x equals 0. Undefined when x equals 0. And since it's undefined at x equals 0, then the original function's not differentiable because that 0 is on the interval from -1 to 1. It's not differentiable on the open interval from -1 to 1. So therefore, we cannot use the mean value theorem for this function over this interval. So let me just write that out. And as we said, since the derivative is undefined at x equals 0, then the function is not differentiable on the interval from -1 to 1. Hence, the mean value theorem is not applicable for the function on the closed interval from -1 to 1. Okay, and again, that's what they started with. Why? Explain why you cannot apply the mean value theorem. All right, the next problem. Find the equation of the tangent line to the graph f of x equals 2x plus sine x plus 1 on the interval from 0 to pi at the point which is guaranteed by the mean value theorem. Okay, so we have to find the slope at that value, and then we can use at the point of tangency, and then from there we can use um, the equation of the line. So let's come up with that. So the first thing I want to do is take the derivative, and derivative of 2x is 2, derivative of sine is cosine, derivative of 1 is 0. Now let's look at, hey, I know f prime of c, and I'm going to set this equal to f of a minus f of b all over a minus b. And again, a and b are the interval from 0 to pi. So what do I get here? F prime of c means I'm going to get 2 plus cosine c. It's going to be equal to f of a. That's f of 0, and I'll write these in the long way first, minus f of pi all over 0 minus pi. Okay, so now here's my function f of x. Let's put in 0. 2 times 0 is 0. Sine of 0 is going to be 0 plus 1. So we have 1. Now we're going to get minus, let's put in pi. 2 times pi is 2 pi. Sine of pi is going to be 0 plus 1. And it's going to be all over negative pi. And again, remember what I said. This f of a, different color here, this f of a minus f of b all over a minus b, that's change in y over change in x. This ends up being the slope of the secant line, which we're trying to find out, hey, that it's parallel to the slope of the tangent line at this value. So let me just simplify this. 1 minus 2 pi minus 1. 1 minus 1 is 0. So we get negative 2 pi over negative pi, which is 2. I see that right now as the slope of the secant line. which again is what we're looking for the slope of. So 2 plus cosine C equals 2. And then let's solve this. So I get 2 plus cosine C equals 2. Subtract 2 from each side. I get cosine C equals 0. And I know since, again, it's going to be at 90 and 270, but since it's between 0 and pi, it's going to be at 90. So C equals pi over 2. Okay. All right, all that work, and we're still not done. We need to come up with the equation of the tangent line. So if I know my x is pi over 2, so now let's come back up here. First, I want to find the point of tangency. Okay, so I know x is pi over 2, and now I'm going to put it back into the original function. So I'm going to get 2 times pi over 2 plus sine pi over 2 plus 1. 2 times pi over 2 is just pi. Sine of pi over 2 is going to be 1 plus 1. So it's going to be pi plus 2. So I now know my point of tangency is x value is pi over 2. The y value is pi plus 2. So this is my point of tangency. Now, again, I told you what the slope of tangency is, but let's just say you didn't see that. So how do I find the slope of tangency? Well, again, the derivative is going to be the slope of the tangent line. So I'm going to find the slope of the derivative at pi over 2. Here's my derivative. So it's going to be 2 plus cosine of pi over 2, cosine of 90 degrees. So we just said cosine of 90 is 0. So that's going to be my slope of the tangent line. 2 plus 0 is 2. So now I know my point and I know my slope. So now I can use the point slope equation of a line, and we get y minus pi plus 2. I'm going to put that in parentheses. Is equal to m times x minus x1. And there is the equation of the tangent line at the point which was guaranteed by the mean value theorem. Okay, and this is the mean value theorem. So there's a lot going on there. That's a great problem. Okay, and let's just finish up uh, this part 4 of the notes with the mean value theorem guarantees that if a function is continuous on the closed interval from a to b and differentiable on the open interval a to b, then there is guaranteed to exist a value of c where the instantaneous rate of change at x equals c is equal to the average rate of change of f on the interval from a to b. Okay, and again, what do we mean by instantaneous rate of change and average rate of change? Here is my endpoints, and it doesn't matter what my function is. There could be a whole bunch of them. And if I have this secant line, secant represents the average rate of change, which is where we got into change in y over change in x. And again, this is the interval from a to b. So this point is a f of a. This point is b f of b. And that's where we got into what I just circled right here. The slope formula for that secant is f of a minus f of b all over a minus b. So what we're saying is that average rate of change is equal to the instantaneous rate of change, which is the tangent. And again, there could be multiple places where this exists. So in this example that I just gave, there might be that one, that tangent line is parallel to the secant line, and then maybe right here it's parallel to the secant line, and there'll be another one. So we would find all those values. Now we've only done examples where only one works, but again, it guarantees that there is at least one value of C. That's what the mean value theorem guarantees. Okay, so let's finish up those notes and we'll work on this in class.